In the last video, we used this same distribution, and we found that the expected value of x, which is also the mean for the random variable x, to be 1.95. We found the expected value of y, which is also the mean for the random variable y, to be 5. And then we found the expected value for the sum of these random variables, which again is the mean for that sum. We found that to be 6.95, and we expected that to happen because we know that this expected value should be the same as the sum of the expected values of the original variables. But now what we want to do is find the variance for each of these. This formula will be to add up the squares of the differences between each of the x values and the mean for the distribution times the probability for each of these values of the random variable. So we're also going to need then each of these probabilities for each of the values of the random variable x. So we have 0.45, 0.35, and 0.20. And then for y, we have 0.3, 0.4, and 0.3. And of course, they should add to 1. And they do. So this first term in calculating the variance of x will be 1 minus 1.95 squared times the probability 0.45 plus 2 minus that mean 1.95 squared times 0.35 plus 4 minus the mean 1.95 squared times 0.20. And that variance turns out to be 1.2475. Now let's do the same thing for the variable y. So the variance of y will be 3 minus its mean, 5 squared, times 0.3 plus and this variance turns out to be 2.4. So now let's find the variance of the sum of the random variables. So that will be first 1 plus 3, so this entry here, minus the mean for the sum of the variables, 6.95, squared times the probability, 0.15. And then we'll add the next entry, 1 plus 5 minus 6.95 times its probability, 0.20. And then we'll continue to do this for every combination of x and y values until we get down to the last one, 4 plus 7 minus 6.95 squared times that probability, 0.05. And when we do this, what we're going to find is that the variance for these two variables, x and y, will turn out to be 3.4475. Now let's note that the variance of x plus the variance of y is not equal to the variance of x plus y this time. And if we checked, we would find that the random variables x and y are not independent. So what we see here is that when the random variables x and y are dependent, then the sum of the variances of the random variables x and y will not be equal to the variance of the sum of the random variables.